This is problem number 8 from section 7.3. Again, this is a problem that looks intimidating when in fact it is not really a very difficult problem. The reason it looks intimidating, I think, is always because of the inverse sign. Cosine inverse and sine inverse and tangent inverse, they always throw students off. Throw me off sometimes. So we've got 3 cosine inverse x plus cosine inverse x equals 2 pi. And they want you to solve the equation for x. Well, 3 cosine inverse of x plus 1 cosine inverse of x, that's just 4 cosine inverse of x equals 2 pi. So that part, that part makes perfect sense, simplifies this problem a lot. Now I can divide by 4 on each side, and I am isolating the cosine, so it's cosine inverse x equals, well, that's 2 pi over 4, which can reduce to pi over 2. So I'm going to write that as cosine inverse x equals pi over 2. Just like in the previous problem, I know the opposite of, or the inverse of cosine inverse is cosine. So I can take cosine of cosine inverse of x, and I do the same thing to this side, so cosine of pi over 2. Okay, well, cosine inverse cancel. I'm left with x equals. Now I just got to figure out what cosine pi over 2 is. Well, let's look at a unit circle. If I go to pi over 2, which is 90 degrees, I'll look at cosine, which is the x value. Cosine's 0 there. So that means that my answer to this problem is x equal 0. So if I have cosine inverse of 0, cosine inverse of 0 here, that gives me, obviously, cosine inverse of 0 is going to be our pi over 2. So we end up with 3 pi over 2 plus pi over 2, which gives you the 2 pi for your answer. So x equals 0 is the solution to this problem.